Chapter 2, Part 4, Forces. What's a force? A force in the simplest sense is simply a push or a pull. When you push something or pull an object, you are applying a force. Now, the source of forces could be gravitational, or electrical, or magnetic, or simply due to muscle effort. We say that force is a vector quantity. Now, what does the meaning of vector quantity? It means that description of a force requires two things: magnitude, that's how much is a force, and its direction, which way. Now, force can, or a vector in general, can be represented by arrows drawn to scale. The length of an arrow represents the magnitude to scale, and the arrowhead shows direction. Examples of vectors: force is a vector, velocity is a vector, acceleration is also a vector. When more than one force acting on an object, we consider the sum of all forces. Now, the combination of all forces acting on an object is called the net force. Now, the net force on an object will change its motion. The main idea I want you to recognize is that forces, they tend to change the state of motion. Now, the unit of a force is Newton, and we abbreviate it by capital N. Let's take an example. If you look at this picture, there are two forces acting on an object, both forces to the right, that's the direction, and the magnitudes are 5 Newton and 10 Newton. The question is, what is the net force? The net force is simply here can be found by adding the two forces because they are in the same direction. So the net force is 15 Newton in the same direction as the two forces. Let's consider this example. We have again two forces, but one is acting to the right, the big one, 10 Newton, while the other is acting to the left, 5 Newton. And the question is, what is the net force? In this case, the net force is the difference in the direction of the bigger one. So the net force is 5 Newton to the right. Third example, there are two forces. One is acting to the right and one to the left, but the two forces are equal in magnitude. The question is, what is the net force? Well, in this case, the net force should be 0 as the two forces cancel out. Let's take a realistic problem. This girl is holding a rock in her hand. Now, the rock is not moving, it is at rest in her hand. There are two forces acting on the rock. Earth's pull, that's a gravity pull, which is downward, and the girl's hand is pushing upward on the rock. Now, the net force on the rock is 0 because the rock is not moving, it is at rest. So the two forces should cancel out. The net force is 0. Two examples of famous forces are weight and tension. Now, weight is simply the force of gravity. It is the pulling force of gravity on an object, which is called weight, or we can call it the force of gravity. Now, when you stretch a spring or a string, then there's a force in the spring. It's called tension. So tension is another example of force. As we mentioned before, the unit of force is Newton. Let's take an example. There is a bag of sugar and it is hanged by a string. Now, the bag of sugar is not moving, it is at rest. How many forces acting on the sugar bag? there are two forces. One force is downward, and that's the pull of gravity, or we call it the weight. The weight is downward. Now, why the bag doesn't fall down? Because it is attached to a string, and this string is stretched. So there's a force of tension which is acting upward on the bag. The upward tension in the string has the same magnitude as the weight of the bag. So the net force on the bag should be 0. In this example, the tension in the string is measured by the scale. The scale is measuring 9 Newton. That's the force of tension. Now, because the force of tension is equal to the force of gravity, that's the weight of the bag, so also the weight of the bag should be 9 Newton. The net force is 0 because the two forces are equal and cancel out. If you put a book on a table, the book is at rest, it doesn't move. Now, there's a force of gravity on the book, downward. But why the book doesn't fall down? Because the table will push it up with as much force as the downward force of gravity. Now, the upward force acted by the surface of the table is called the support force, or sometimes it's called the normal force. So in this example, there are two forces acting on the book. One force is downward, and that's the force of gravity, or the weight. The other force is the support force, which is upward. The net force should be 0 because the two forces are equal and cancel out. As you push on the ground or on a scale with your foot, the upward support force is as much as the downward pull of gravity.